Hi everyone, this is Talk Wisdom, welcome to my channel. Today we will talk about plate tectonics. But before, subscribe to my channel, share, and now enjoy this new video. So, what is plate tectonics? Plate tectonics is the model that explains the actual disposition of the crust. It was born in 1590 with a Dutch cartographer named Abram Ortelius. He saw that borders of continents, like for example Africa and South America, matched perfectly. In 19th century, study of fossils demonstrated that many years ago in North America and Europe there was the same flora. Everything led to think that before continents were in contact each other. But it was just a supposition. They didn't know how from continents linked together. Nowadays there are a lot of continents all separated. And here comes Alfred Wegener, that was a German geologist that elaborated the theory of continental drift. This theory said that at the beginning there was just one continent called Pangaea and just one big, very big ocean called Pantalassa. Later, Pangaea fragmentized up to the current configuration. As proof for this theory, it brought similarity among species of fossils lived in the same period in South America and Africa. Considering that these animals couldn't cross the ocean, they had to be together. Wegener said that there were solid plates that float on a solid layer, but more plastic, located between Morovic discontinuity and Gutenberg discontinuity. If you want to know something about this subject, you can see the first video that talked about Earth's internal structure. What means to this theory is how everything works. Which is the engine of all of this? We can find the engine in the mantle. Convective movements. And now we have the born of actual tectonic plates. It's easier in this case to divide the Earth's internal structure in lithosphere, that is the solid part, and asthenosphere, that is plastic. In the asthenosphere there are convective movements. What are convective movements? These movements are exactly the same that we have in a pot of boiling water. Hot water goes up, and considering that it's contact with the atmosphere, it cools down. It pushes to the side by warmer water below, and then it goes down, and so on. And the same in a asthenosphere. There is warm magma that it goes up because of the density. It's warmer, so it's less dense. It arrives in contact with the crust, so it cools down. In the meantime, below it, there is more warmer magma that pushes this to the side. Cooler magma flows away and then it goes down because it's colder, so more dense. This convection causes movement of the crust because of the dragging of the crust by magma. So there are different movements of plates and three different boundaries: divergent, convergent, and transform or transcurrent plate boundaries. Constructive or divergent plate boundaries are those ones where two plates step away each other. In this case, we have new crust created by the ascent of new magma. This magma melts because of a lower lithostatic pressure due to the ascent. All this happens in the bottom of the oceans, where there is the formation of a very long mountain range called Middle Ocean Ridge, formed by the emission of basaltic magma by submarine volcanoes. If it happens in a continental crust, there is just the thinning of the crust and the formation of a rift zone, as in Africa nowadays. And when there is no more continental crust, everything is submerged by the sea, and we have the formation of an ocean, exactly like in the Red Sea nowadays. Another kind of boundary is convergent or destructive. These are where two plates collide. There are different kinds of collision depending on the kind of crust involved in collision. If two continental plates collide, there is the formation of a mountain range like in Himalaya, where collided Asia and India. So there is a cross-doubling. If two oceanic plates or also a continental plate and an oceanic one collide, there is the subduction. So the heavier plate, or better, more dense, that usually is oceanic crust, slide down to the lighter one. So there is a zone with very high pressure because of the extremely high friction between these two plates. For this reason, there are a lot of earthquakes that are deeper farther we are from the trench. We will talk about earthquakes in another episode. The trench is the zone where the heavier plate slides down to the lighter one. Because of the sinking of the plate, that is rich in water considering that it is oceanic, there is the hydratation of the mantle. Water is a depolymerizing substance, so it means that it lowers the melting temperature of mantle. So we have partial melting of mantle. This brings to the formation of magma that could raise up and could form volcanoes, very explosive one that we could find around the Pacific Ocean, for example. We will talk about volcanoes in the next episode. This is what happens below the crust, but what do we see above? If two oceanic plates collide, what we see is a volcanic island with very explosive volcanoes, as in Japan. If oceanic plate and continental one collide, what we see is a mountain range. This range is because of accumulation of sediments of the oceanic plate that is scraped by continental one. But we have also volcanoes, as in South America. The last kind of boundary, but not least, is conservative, where the crust is not created or destroyed. They are represented by strike-slip faults or transform ones. Considering that fault is a very big subject, we will talk about them in another episode. Obviously, all these things that I told you are n members of infinite possibilities. In nature, nothing is black or white, but there are a lot of shades. That's all for today. So, if you enjoyed this video, thumbs up, share, leave a comment and subscribe to my channel. Big ciao from Doc Wisdom. See you next time.